Today we're unpacking one of the absolutely most mind-bending thermodynamic paradoxes I've ever come across. This is a phenomenon that literally had scientists scratching their heads for decades. And it's going to challenge a fundamental rule of physics you probably thought was unbreakable.
So, picture this scenario. You take two identical cups of water. One is filled with boiling hot water at 80 degrees Celsius, the other just cool tap water at 20 degrees Celsius. You open up your freezer and you put them both inside at the exact same time. Now, common sense tells us the cool water wins this race every single time, right? Logic dictates the hot water has to cool all the way down to 20 degrees first just to get to the starting line where the cool water already is. So, which one actually freezes first? Take a second to really think about it.
Okay, let's dive into this, because the answer totally defies common sense. Against all odds, under the right conditions, the boiling hot water at 80 degrees Celsius will actually turn into solid ice before the cold tap water does. Yeah, no joke, you heard me right. The hot water beats the cold water to the finish line. It sounds absolutely impossible, kind of like a glitch in the matrix of basic physics, right? But it is a very real, heavily documented scientific phenomenon. This whole mind-boggling thing is known as the Mpemba Effect. Basically, it's a thermodynamic paradox where hot water freezes faster than cold water under specific conditions. Now, for a long time, this sounded like a complete scam. It just broke the laws of physics as we understood them for decades. But honestly, the most incredible part of this story isn't even the physics itself. It's the person who proved everyone wrong. Because this wasn't discovered by some Nobel laureate in a multi-million-dollar lab. No, it was brought to light by a 13-year-old kid who literally just wanted to make some ice cream.
Let's travel back to 1963 to a high school cooking class in Mpemba, Tanzania. Meet our underdog, 13-year-old Erasto Mpemba. So the assignment was to make ice cream, but space in the school's freezer was extremely limited. The standard procedure was to boil your milk and sugar mixture, wait patiently for it to cool down to room temperature, and then put it in the freezer. But young Mpemba, he realized that if he waited for his mixture to cool, someone else in the class was absolutely gonna swipe that last precious spot in the icebox.
So he took a massive gamble. Instead of waiting, Mpemba bypassed the cooling phase entirely. He just shoved his boiling hot milk and sugar mix straight into the freezer, right next to his classmates' pre-cooled mixtures. Well, when he opened that freezer door just 1 hour later, he was greeted by a miracle. His ice cream was frozen solid. Meanwhile, his classmates' mixtures, the ones that started out cooler, they were still just this slushy liquid. He kept experimenting with this, and eventually teamed up with a visiting professor named Dennis Osborne. Together, they actually co-published a groundbreaking scientific paper on this very effect in 1969.
But as you can imagine, getting to that 1969 paper was a rough road. When Mpemba first noticed this happening, he did what any student would do. He asked his high school physics teacher to explain it. But instead of encouraging the kid's curiosity, the teacher publicly mocked him right in front of everyone. He literally stood there and told the entire class, "That's not universal physics, that's Mpemba's physics." Man, imagine being a 13-year-old and having an authority figure completely dismiss your real physical observation as a total joke. But Mpemba, he didn't back down. He trusted his own eyes over textbook assumptions, and ultimately, he was proven 100% right.
So the crucial point is, how exactly does this happen? How does hot water, mathematically and physically, beat cold water to 0 degrees Celsius? Well, the boiling water actually uses a combination of physical mechanisms to basically speed up its own freezing process. It essentially cheats the race. And it all comes down to 4 main tricks that hot water has up its sleeve. Let's break them down.
These mechanics boil down to 4 main tricks. Number 1, mass loss through evaporation. Number 2, internal convection currents. Number 3, gas expulsion. And number 4, melting the frost layer. Let's look at how these 4 things build the absolute perfect storm for rapid freezing. Okay, the first trick is mass loss, otherwise known as evaporation. Think about a pot of boiling water on the stove. It steams aggressively, right? Well, as that steam escapes into the air, those water molecules are carrying away massive amounts of thermal energy. But here is the real kicker. Because so much water is evaporating as steam, by the time the hot water actually reaches freezing temperatures, there is literally less total mass of water left in the cup to freeze, compared to the cold container. And hey, less water means it takes way less time to freeze solid. It's just simple math.
Moving on to the second trick, what we can call the liquid engine or convection currents. See, hot water doesn't cool down evenly. Inside a freezer, the top layer of the water cools ultra fast because it's exposed right to that freezing cold air, while the water sitting at the bottom of the cup stays hot. This giant temperature difference creates these really intense internal currents. The hot liquid surges up to the top, dumps its heat into the freezing air, and then sinks right back down. This turbulent, churning cycle acts like a literal engine, cooling the overall volume much, much faster than a cup of perfectly still, stagnant cold water.
All right, our third trick is gas expulsion, or outgassing. You see, normal tap water isn't just pure H2O. It's got dissolved gases in it, like oxygen and nitrogen. But when you heat water to a boiling point, you actually bubble these dissolved gases right out of the liquid. Now, why does that matter? Because dissolved gases act as subtle insulators, and they actually physically change how ice crystals can form. The cold water keeps all those insulating gases trapped inside, which slightly delays its crystallization. The hot water, on the other hand, expelled them all, giving it a much clearer, faster path to turning into ice.
The fourth and final physical trick happens right at the base of the container, melting the frost layer. So in a traditional freezer, the shelves are usually coated in this thin layer of frost. When you place a scorching hot container on that shelf, it instantly melts the frost directly underneath it. This creates a wet, direct liquid contact patch between the container and the freezing metal shelf, which allows heat to transfer out incredibly fast. The cold container, though, it just sits on top of the dry frost, and since trapped air inside frost acts as a thermal insulator, that cold container is basically sitting on a tiny little blanket that delays freezing.
Now, even with those 4 physical tricks explained, for a long time, hardcore skeptics in the scientific community still claimed the Mpemba effect was nothing more than an experimental error. They just couldn't accept it. But let's leap forward to the modern era. In 2017, a group of theoretical physicists decided to tackle the Mpemba effect using statistical mechanics, and they discovered something even wilder happening on a microscopic energetic level.
Their breakthrough was this brilliant realization about energy. These physicists found that when a system is extremely far from equilibrium, like say a cup of boiling water suddenly tossed into a sub-zero freezer, it doesn't have to step down its energy levels one by one in a linear fashion. Instead, the high-energy state gives the system these wild fluctuations, and these fluctuations allow it to bypass intermediate energy steps entirely. It is exactly like taking a steep mountain pass shortcut to get to your destination, instead of slowly walking down every single winding road on the map like the cool water is forced to do.
So, what does this all mean? Well, it brings us to a really beautiful realization. The Mpemba effect reminds us that nature is just full of surprises. Even something as incredibly simple and mundane as a cup of water sitting in a freezer can completely shatter our baseline expectations of how the universe works. It teaches us to question common sense, to embrace actual observation over assumed knowledge, and to always remember that sometimes a 13-year-old kid who just wants some ice cream can literally outsmart the established laws of physics.
I want to leave you with a bit of a challenge today. Have you actually tried this experiment at home? I mean, it is incredibly easy to set up. I highly encourage you to test it out. Carefully, of course, no burning yourselves. And let me know in the comments below if your hot water froze faster, or if you just ended up making a massive mess in your freezer. If you enjoyed this deep dive explainer and love having your mind blown by structured science, please hit that like button, subscribe for more weird science, and keep questioning the world around you. Thanks for hanging out with me.